Hello, today I'm going to introduce the concept of pointers. So, let's say we have a problem like this. We want to swap two variables. So, I have two variables A and B, A is 5, B is 10, and I want to swap the two. So, I make this function, very basic function, this swaps two values. So, let's see what happens. I'm going to run it. Nothing happened. The values weren't swapped. Why is this? The reason why is because when I passed A and B into this function, I'm not passing the variables themselves. I'm not actually passing in A and B. What I'm passing in is 5 and 10. This is called passing by value. So I'm just passing 5 and 10 in here. This is the exact same as if I just wrote 5 and 10. So of course, in here, 5 is swapped with 10, sure. But after, that's not the case. When the function's done running, that's not the case. So, how can we pass the actual variables in themselves? How can we pass by reference? The answer is pointers. So pointers look like this. So pointers are declared like this. So you have the star that basically means this is a pointer, and you put that after the variable type. So this means this is pointing to an integer variable. This is an integer pointer. And I'm going to set it to A like that. And notice I put the ampersand there. And the reason why is, well, think back to when you did scanf. That's not it. There we go. When you did scanf, you were taught to do it like this and you might not have been explained why this is the case. The reason why is because scanf accepts a pointer because it doesn't want to set the value that's being passed in here to whatever integer the user types in. It wants to actually set the variable itself. So basically this is referencing this variable A. So if I were to represent this visually, so we have variables A and B in some space. These are memory boxes. This is memory in your RAM, let's say. Now I have a C pointer that's basically just pointing to the memory location. And same with D. So that's what's happening here. C is pointing to A and D is pointing to B. So let's go back to this and let's update this to actually make it pointers. So first of all, we're going to put stars here because we're saying we're passing pointers instead. So we'll pass C and D. You could also pass percentage %A here too, or ampersand A, just like you would do for scanf, but we're going to do it this way for fun. So we got to update this a little bit. So right here, num1, num2, these are pointers. I can't just type this because int temp, this is an integer. This is just storing the integer values. But this is a pointer. This is not the actual variable itself. So what I have to do is I have to put a star here. This is called dereferencing because now when I put the star here, again, I'm fulfilling this. It's pointing to A. If I don't put the star here, then it's just this. So I put the star there to basically say I'm pointing to A. Alrighty, so back here, and I'll do the same for this to basically say I'm setting the integer variable that num1 is pointing to the integer variable that num2 is pointing to. And that's how that works. So now let's see what happens when I run it. There we go. It actually works. It passes. Now, if I want to print if I want to print the pointers, here's what I have to do. I'll put before swapping. So dd, if I put this again to print the variables, I have to put the star there to dereference and to say I'm pointing at A and B. So I want to print A and B. But if I want to print the pointers themselves, then the variable is percentage %P. And then I don't need these stars. And this is what it looks like. So you have 10 and 5 again. That's great. And here are the pointers themselves, and they print out these numbers. These are hexadecimal numbers. That is the memory address. So right here, this would be, I forget what it is, 0061FF14. 0061FF14. That's the memory address of of this block of memory that A is being stored. That's what that means right there, because it's set to the address, the memory address of the variable itself. So that's how we can print pointers. Now, the question is, can we point to pointers? Absolutely we can. We could do that with double pointers, which look like this. This looks like fun, doesn't it? Well, what this means now, these double pointers, let's go back visually. So these pointers exist in memory too, right? These variables exist in memory. These pointers exist in memory. That's great. So now when we have E double star, that's pointing to the variable, to the pointer itself. So now we're pointing to the pointer. So now the question becomes, how can I still access A and B from this? Well, why not? Let's try it. So I'll do D, D, and then this is E and F. So if I do 1 star, then I'm dereferencing it once. So that means that this is the same as writing C, which is right here. Because when I put 1 star, then I'm only going in one direction. I'm only doing one dereference. I need to put the second star to do the final dereference. So I put the second star there, and I do the same for F, and let's see what happens. There we go. We get our integers. And if I want to print the pointers of E and F, that E and F are pointing to, look at this. I only need 1 star because, again, that's pointing to C and D. It prints the exact same memory addresses. And if I want to get the memory addresses of E and F themselves, there we go. They're different memory addresses. Everyone has a home. So now, how do we swap the pointers themselves? And the answer is this piece of code. So, swap pointers. We're passing double pointers because, again, when we swapped values, we needed a pointer to the integer variables that we were swapping. That way, the code would swap the variable values instead of just the values themselves. So here, we're doing the same thing with pointers. So all we do is we add a star. This time we set temp to a pointer variable, and we still do 1 star here again because we're swapping the pointers. So swap values. Swap values was for strictly these right here, A and B. Oh, that's not a good line. That's a better line. Swap pointers, on the other hand, I'll just put swap P. Swap pointers is referring to this. Yes, I'm doing green lines. I'm making the colors different for fun. So we're swapping C and D now, which means we only need 1 star because we're only going one dereference. So now let's see what happens. So if I do swap pointers, I can put E and F in here, or I could do this. That's fine. Don't forget your semicolons, people. Now let's see what happens. After swapping, let's see. Interesting. So we see here's C and D. This is the address of C. This is the address of D. Now this is the address of C and this is the address of D. That's the address that they're pointing to. Interesting. So see how they passed. It looks like A and B passed because now we're printing 5 and 10. But that's not the case because what happened is this mean old swap pointer function, it's not mean because we actually want to do something with it, basically said, you're not pointing to this anymore. You're pointing to that. And this, you're pointing to that. Or actually, no, wrong one. Sorry. It's this one. So D, you're no longer pointing to B. You're pointing to A. C, you're not pointing to A anymore. You're pointing to B. So it swapped where these pointers were pointing. That's how it works. So, and I can prove this. I can go back to just printing this. I'll just say after all swapping to show. See, A is still equal to 10 and B is still equal to 5. So we didn't swap A and B by swapping the pointers. We just swapped the pointer values themselves. So you could do another one of these. You could do a triple pointer. You could do this and G and then dereference E and then do that. And then you can write swap double pointers and do the same kind of thing. You can keep doing this for as long as you want. You can go like this and have all the fun you want. So, I hope this helps with your understanding of pointers. Thank you so much for watching and have a good day.